Okay, let's do this! Welcome to Advent of Code Day 4. As always, I'll drop a link in the chat and pin it if you want to do this yourself. Advent of Code is a yearly programming challenges with 25 days of coding challenges, and I always have a lot of fun and I try to stream them every day. So yeah, today is day 4. We've done the previous 3 days. If you want to watch them, go check the channel. So let's jump in and start reading today's challenge. Day 4, Camp Cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare the section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair, your puzzle input. For example, considering the following list of section assignment pairs: 2 to 4, 6 to 8, etc. For the first 2 pairs, this list means within the first pair of elves, the first elf was assigned section 2 to 4, so 2, 3, 4, while the second elf was assigned section 6 to 8. The elves in the second pair were each assigned 2 sections. 3, 4, 4, 5, yes, okay. The elves in the third pair were each assigned 3 sections. One got 5, 6, 7, while the other got 7, 8, 9. This example list uses single-digit section IDs. To make it easier to draw, your actual list might contain larger numbers. Okay. So for the example, they have single-digit, but in the code that we will get, it probably will have like 1, 2, 3 dash, etc. Okay. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. Sure. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7. And 6, 6 is fully contained by 4, 6. In pairs where one assignment fully contains the other, one elf in the pair will be exclusively cleaning sections their partner will already be cleaning. So these seem like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Okay, so that's very doable, I think. Let's see. Let's look at the input. It's always nice to have it visual. So yeah, these are bigger pairs, but it's basically first split by comma, then split by that, and that builds a range. Okay. Let's see. So let's build a class this time, just for fun. Public class range, and then we say public int from set public int to get set. The constructor int from int 2 from is from 2 is 2. We can also have a public range string raw, and then we do string parts is raw dot split this. To throw argument exception, we expect it to values. Okay, so let's. Usually you don't need this stuff, but it's always nice to have some validation raw, and then we do parts length. Okay, and then we do this, and then we do int.parse parts 0, int.parse parts. I probably can't do that right. Let me see. I actually don't know how to call the. Normally you do it here, like you do blah. That's a good one. We just do this. Is int.parse parts 0. 2 is int.parse parts. Okay. So now we have that. Public bool overlap range over. So then we can do if other dot from is larger or equal to from, and other than 2 smaller or equal to 2, return true. Else we do the inverse, false, else return null. So in this case, other within R range within other not contained. Right? So if this is either true or false, so if this has a value, one either contains the other. So if we need to know that later, we can figure that out. And we can probably also do public IEnumerable int values, and then we can do for int I is from I smaller or equal to 2, increment I, and then we can do yield return I, right? What's it complaining about? For int I is uppercase from, I smaller than 2, yeah, this should be good. This is the getter, right? Like this. So now we have everything that we can do with ranges. So we'll figure out what to do. So for assignments is input.toLines. We probably want to do split. And we split by a comma, right? Comma. Let me do select x.split by comma, and then we do as x new range x. Okay. So now this becomes to list, and this becomes a list of range from, range A, range B. So that's our input parsed. So first we split it to lines, then we go for each line we split it by comma, and then we transform it into two range elements. Should be here. All right. So now we can do int overlap count is input. Assignments count x dot a dot contains B. X sub B. Console.writeLine has value like this. Assignments. Assignment with full overlap, and then we do overlap count. Overlap count. Okay. Let's see. 582. That's a lot. How many lines are there? Let's see. Assignment is 1,000. Okay, so that's a lot of overlap. Jesus. I didn't expect that many. I hope it's correct. It's correct. Okay, so it was that easy. Let's see part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the else would like to know the number of pairs that overlap at all. Okay, so where there's any overlap. Okay, let's do that. Hey, thank you for joining. Okay, so now we change our logic. This is contains, and now we do an has overlap. And basically that would be and I usually draw this out, so let me think about it. Because you have a from until, yeah, so that one, the 2 needs to be larger or equal to the from, yes, so this becomes 2 becomes larger or equal to other from, and that, and then the from is smaller or equal to the other dot 2. Yeah, and from smaller or equal other dot 2. I believe this is the correct one to count overlap. If not, I'll have to do it in my head, but it should be fine. So let's do has overlap with B. Any overlap. That's a lot. 893. Let's see. Boom, and we have it. Okay. 4 quick puzzles this year. Yeah, I actually spent more on day 1 and 2 than on 2 and 3. So this was fairly easy. Let me just explain what I did here for the overlap, because I got taught this a long time ago by a friend, and it's basically if you have 2 values, the universal constraint that you have is always that, and I should probably draw this as a line. Let's say this is a value and this is a value. The universal rule is that this one always has to be smaller than this one. And the same way, this one has to be smaller than that one. So like you can draw all kinds of overlap. Like you have this one here, and you have the opposite, and you have it contains, and it contains the other way. In all these cases, these rules ring true, right? It's always this compared to this. You can always do that. And it's always the same relative position. So if you check those two areas, that this one, so the second one, the start line is before the end line of the first one, then you always have an overlap scenario. So, and the same is true for the other ones. So it really helps if you don't know how to do this to just draw all the cases out and then you know exactly how to which things ring true in all scenarios, and that is how you can test it. So yeah. So this was fairly easy. I did more work than I needed to, because I didn't even need this. Basically only these two functions were what was needed. But instead of always doing things in line, I was like, okay, you know what? Let's create a class. I have no idea what they will ask of me. Let's just do it nicely. Have some helper class to just treat it a bit nicer. So yeah, I went a bit overboard. It was not needed yet, but it was still fun to write it like this. So yeah, a very short stream, I think. So yeah, I guess the weekend puzzles, at least the first weekend puzzles this year, weren't that hard. Usually the weekend puzzles take a bit longer, but yeah, today was another quick one. So yeah, I guess I'll end the stream here, and hope to see you guys tomorrow again. Bye bye. Let me find the stream window, and I click end stream. Bye bye.